ODE. So here we got dy over dx equals this fraction. So let's separate the variables. So y cosine y minus x with dy, and it's kind of cross multiplying y dx. Okay, so y cosine y dy is a minus x dy equals y dx. Okay, I mean this part is fine because y times cosine y is the function of y dy, but we are in trouble here. For dy we have to have a function of y. For dx we have to have a function of x. That's not the case. So this is not separable. We cannot do in this way. Then let's try to make it linear in the sense, what is a linear? Suppose we have y, that's the dependent variable, and then when we have dy over dx, there can be function of this independent variable x. So we can have function of x, we can have function of x here as well, but we can always divide by that. So when we have dy over dx plus some function of bottom y equals some function of x, okay, something function of x, then this is linear in y. In that case we can find the integrating factor and solve. Okay, it's for y. But the problem is dy over dx is here, but we got a giant fraction and we can't separate. But let's think other way around. Dy over dx, that means y is dependent variable, x is independent variable. Another case could be x dx over dy. Here now x is the dependent variable, y is independent, and here we can have a function of y. Function of y, here too, function of y. In this case, this will be still a linear, but linear in x. Okay, we can flip this fraction, we can flip this as well. Then we'll have two terms in the top and one on the bottom. Maybe we will be able to write this one. Let's try. This is same as dx over dy equals y cosine y minus x on the top all over y. Now we can separate into two fractions. Dx over dy equals y cosine y over y. I mean, do not cancel. Y cosine over y. Oh, in that case it cancels y, so cosine y from first fraction. Okay, just from the first fraction. Y cosine y over y is cosine y minus x over y. Okay, looks like this is the case here. Let's pull x over y to the left. So we have dx over dy. This means add x over y to the both sides, plus we can write 1 over y times x. So x over y is same as 1 over y times x equals cosine of y. Okay, let me put in this way. Okay, here x is dependent variable, y is independent. So this 1 over y is a function of y and this is function of y. So this is in fact linear. Linear ODE in the dependent variable x, linear in x with respect to independent variable y, by the way. Now after we have this situation, we can solve. To solve a linear, we find integrating factor. Let me write y of integrating factor mu x, but here y is the independent variable, so mu y equals e raised to integral px dx. But in our case py, I mean it will be y. Anyway, this is the function 1 over y dy. Okay, the roles of x and y are interchanged. And this one is e raised to antiderivative of 1 over y is ln absolute y, but it's given in the question y is positive, so no need to put absolute value. E natural log when they are adjacent, this is simply y. Now we multiply this linear, okay, I'm just writing star just to mention this equation. We multiply both sides of this equation by y. Then the equation star, I'm just going through the standard procedure. After we find the integrating factor, we multiply both sides of this equation by this integrating factor. Then the left hand side automatically becomes derivative of d over dy, unfortunately not x, derivative of dependent variable which is x times integrating factor which is y. Okay, this will be always automatic in the left side, equals, we need to we are multiplying both sides by y, so y cosine y cosine y. Now integrate both sides with respect to y. Okay, then this will be simply x times y equals y cosine y dy. So we are integrating both sides with respect to y. Now the right hand side is a product, so we need to use integration by parts. What is that? When we have u and dv, so antiderivative of u and dv is uv minus integral v du. Okay, integration by parts. Okay, let me write slightly better way here. So here u is y and remaining is dv cosine y dy. We need du, derivative of y is 1 with respect to y. Integrate both sides, v equals sine y. Okay, then this is x times y equals, using this integration by parts, uv, so y sine y minus integral of v du, so v du sine y 1 dy, just sine y dy. Now this is y sine y minus antiderivative of sine y is negative cosine y, but the negative, so it's positive cosine y plus some constant. Okay, now we divide by integrating factor which is y. So we solve this for x, unfortunately not for y. So x equals then y sine y plus cosine y plus c all over y. Divide each term by y, so y sine y over y, simply sine y plus cosine y over y plus c over y. So the solution is given x equals a function of y. Final answer.